I would like to thank all co-organizers and co-hosts for bringing us here for this very stimulating conference, and it's my pleasure to share with you some perspectives on planetary and human health in the Anthropocene. We have already heard some aspects in this morning, and I will just very briefly touch on these items, and you're also very welcome. I'm happy to share the slides afterwards, so I'll try to be brief and can share with you some of the details later on. So just to start out with, how is the Anthropocene embedded in Earth history and what does it mean for human well-being? And what is the bigger picture of planetary health and related to human health? I'll try to come back to Professor Innocent's issue also with natural traditional medicine compounds, how that relates. And one thing that I always like to emphasize is really how to make good use of scholarly knowledge. It's indeed a topic here, how to integrate and how we can build together an epistemic web that tells us not only what we know, but also how well we know it and where the limits are and how to improve. So just very briefly, I think Paul Crutzen was indeed the person who first realized that we have already left the stable Holocene and that we are in a new epoch in Earth history where really human activity is changing the planet at large. So climate change indeed is only one key facet of this whole thing, but we are really shaping the planet, and the way I like to phrase it is really to give also some hope and perspective to the younger generation to really say we are shaping the planet. So let's try to get it right. And I'll get back to this. It's actually a huge achievement of our species, right, of Homo sapiens, to be able to shape the planet consciously and more or less well done, right? But it's actually a huge achievement, but it's also obviously a challenge and a threat to our subsistence, as I will show you. And Cardinal Turkson had shown this picture, and I just want to point out to you, if you look in the middle, I will then zoom out into the longer times of Earth history. But if you look from 10,000, 12,000 years before now, until recently, we had very stable conditions. And the Neolithic revolution took place about the beginning of this stable interglacial period. And then we had very stable conditions. So all our civilization developed in that time span. And if you look at the end, the same plot, I just added the years, roughly the level where I wrote 1950 and 2000 is roughly the level where these trace gases, carbon dioxide as a main greenhouse gas and the other greenhouse gases, where they stood in 1950. And that's where you see why some colleagues proposed to really nail down the beginning of the Anthropocene around 1950, where this great acceleration really took place. Because humans have been influencing their environment indeed for 10,000 years, megafauna extinction and whatever, even longer. But this enormous shaping the planet is really taking place since the mid of the 20th century. And you can see it also with the increase in energy consumption, radiocarbon, plutonium, so with this nuclear testing, right? So there's really a very sharp spike of how we started to not only influence the planet, that's where the wording is important, but really to shape our planet entirely, except for its interior, but all the surface we are shaping. And so just very briefly again, to zoom out, and later on, if you want to dwell on it, again, I'm happy to circulate the slides, but we now have really very strong evidence that this is unprecedented in this way, this massive short-term change that we have here. And if you just look back where we stand now, it's interesting to reflect, right? Within one lifespan of 75 years of Homo sapiens, we have changed the planet much more than what has happened 1 million years ago. Right? So it's 1 million versus 75 years. It's really a big difference, multiple orders of magnitude. And our current levels of CO2 go back to about 3 million, 5 million years ago, when the planet was 3 degrees C warmer and the sea level was 20 meters higher. And if we would continue like this, we would resort to these similar levels, but it will take some time, right? So there's a lot behind it. But the point is, it's really a very strong signal that we are having here. We see it in practice with planetary health aspect now that with deforestation, we had this topic a couple of times already. We can also attribute how much, for example, regional precipitation in the Amazon is mostly influenced stronger by deforestation, is the main culprit for increasing droughts locally, whereas the overall temperature is obviously mostly dominated by the global change, by global greenhouse gas increase. And there is currently this discussion, I'm not an expert, but whether we are already in the sixth mass extinction or not, right? How bad is it really what we are doing to other species on the planet in the course of Earth history, what is happening now? Again, I'm just progressing swiftly to save some time and just want to highlight the key things. Indeed, air pollution is one of the top 2 risk factors, right, for human health. And it costs us on average as human beings on this planet 3 years of loss of life expectancy. And this is also healthy life expectancy loss. And if you look, only 2 years are attributable to tobacco smoking. Of course, that is focused on the tobacco smoking population, and 3 years then for the whole average. So again, these are very big numbers. Most other risk factors have less of an impact on life expectancy. Only few are higher. And a major fraction of that can be attributed to fossil fuel combustion. So that's where we have, again, the co-benefits of mitigating fossil fuel combustion go for mitigating climate change and also improving health outcomes and life expectancy. So there is a lot known in these areas, and we are currently also digging a bit deeper into these issues, why it actually is that air pollution is so noxious. There are still open scientific questions, which chemical processes in our lungs are actually the culprits for having such a strong effect of fine particulate matter, for example. And one recent issue is that we think these air pollutants act as catalysts. It had long been thought that they generate a lot of hydrogen peroxide that then triggers inflammation in the body, but we think the hydrogen peroxide is well buffered by our body. Without it, actually, we would be immediately dying because of all the microbes getting into us. We have our self-defense like that. But then the air pollutants convert this hydrogen peroxide very efficiently into OH radicals, which react with everything and then also really deteriorate our own tissue and lead to serious health effects. And with this, I'm already coming to the last aspect here and trying to bridge the gap back to Esther's presentation. And indeed, we also by now learn more about how air pollution is also influencing allergies, which is one major branch of diseases that are strongly on the rise globally. There are various ways how climate parameters and air pollution can influence allergies. But one interesting pathway is we have this signaling in our immune system, and the air pollutants can modify these signaling molecules and trigger a stronger feedback. And interestingly, in traditional medicine, cinnamon bark has long been known as one agent also to dampen fevers, etc. And nowadays, we also can identify these pathways, the signaling pathways, pattern recognition receptors in the immune system, specifically these TLR2, TLR4 receptors can be blocked by cinnamon. And like this, you can sort of dampen the fever and drive it down a bit, right? And there are, of course, lots of other medicines, we heard it earlier on, that are known also from traditional medicine. Now, the last thing I wanted to address is really the attempt of integrating, so what is done here, which is very nice to bring together different forms of knowledge, but then also to make it openly accessible, right? For this, we need open scholarship, open access, open data, open source. But actually, it's not quite enough. We need one step further, that's open processes, including open peer review. And there are many ways, right? You can still maintain anonymity for good reasons in various fields, but still make it transparent. And like this, we can show from the original manuscript, which is shown in the lower left corner, all the way up to distilled formats like reports or so, and in the center are, of course, the traditional journal articles here still, or preprints. And then we can also assess in public how well we know those things, and then really integrate and identify also, according to critical rationalism and modern epistemology, where the limits are and where it's actually best to focus our efforts to advance science, again, for the benefit of science and society and scholarship. And with this, I thank you for your attention.